briefly tell you what's on your test. I'm not going to talk at you very long because, you know, this is a pretty, I don't know, basic test, and there's not a lot. There's really not a lot once we start talking about it. I gave you this sheet here, and that has all the formulas, the integral formulas you should know, right? It's got the power rule, it's got your trig on there, it's got your minor trig, it's got 1 over x, e to the x. Remember, the interval 1 over x is ln of the absolute value, right? Have you done that part? Okay. Right, so the calculator for this one thing is, you know, like, when you find a maximum, you want to show me calculus. Okay, I just gave you a calculator. All right. Remember, the integral of 1 over x is the ln of the absolute value of x. We talked about that yesterday and why that was true. So don't forget to put those as absolute values.
Unless it's like x squared or x.
Unless it's something that's positive and the absolute value doesn't matter. Okay. She's down at college readiness workshop.
I don't think it's for today.
It's not for
Did
today.
they say today?
Looking for rice?
Oh
No,
no, we
no.
found it. Thank you though.
Okay.
I don't think they're for today.
Okay, I'll save it. Style page. She's got style. Okay, so I have all the integrals there that you should know because they're just opposite derivatives, right? Okay. The new rules we learned was the different bases. We did that yesterday. The integral of a to the x is a to the x divided by the ln of a. Right, we learned that yesterday. The derivative of a to the x is a to the x ln a. And the derivative of log base a is 1 over x ln a. So you've got these ln base floating around. So you should know those, okay? Most of this test is multiple choice, except for the a to the x's because there's not a lot of AP problems on them. So they're just not, there's not a lot. So some of those are free response. This is going to be mostly non-calculator, it may be all non-calculator, because we really don't need a calculator for much of this. The first day we did Riemann sums. You should know the formula for the Riemann sum. You should be able to, remember if you have even rectangles, delta x is b minus a over n, and the ci is a plus I delta x, right, where a is where you start, delta x is the width of the rectangle. So you should be able to write an integral as a Riemann sum or vice versa, all right? The vice versa, writing a Riemann sum as an integral is what caused you some difficulty. Those questions are going to be multiple choice because there's multiple answers possible, all right? So and you expect one of those, I mean, you don't expect a lot of that, all right? Fundamental theorem of calculus, 2 parts to it. The integral of the rate is the net change. It's f of b minus f of a. It's just a definite integral, right? No big deal, okay? Part 2, which I didn't give you any problems on, but the derivative of the integral is the function evaluated at the limit times the derivative limit. So just to do one of those really quick, because I forgot to give you one on your review. Let's make one up. Stop that. Okay, where's the thing? I'm going to put my smart board. All right. So what I mean by the part 2 part is the integral from I don't know 2 to x. Start with something easy. Make that t. Sorry, sine of t squared dt. I'm going to take the derivative with respect to x. You know what that is? It's very easy.
Sine of x squared.
Sine of x squared, right? The derivative of the integral is a function. Okay, you should be like, oh yeah, that's really easy because I did my homework. All right, this is sine of x squared. Now, when there's a function up there, fundamental theorem of calculus, make up a different function. Let's do x cubed. Let's do x over 1 minus. Sorry, I can use x's, but they don't like that. So t over 1 minus t dt. So you remember what I do here? What do? Just plug it in, and you have to multiply by the derivative limit, right? So I'm going to get t is x cubed, so it's x cubed over 1 minus x cubed times questions about it. It's not difficult. It's very, very easy.
The T on top,
Yeah.
wouldn't that make the x cubed on top be like 3x to the
Yeah, you can
fifth?
simplify. This is going to be 3x to the fifth or minus 6.
Oh, I didn't see the direct square on the side.
Is that right? Oh, you didn't see that. Okay. All right. Is that okay?
Why
that's-
doesn't the two affect the equation?
What to? Okay. So I'll show you with. Let me show you. Can I show you with a top example because it's easier? Okay. Actually, I can't. We can't integrate these. Can I get rid of this? All right. So look. Don't do this the long way. I'm gonna do one that I can do that I can do. Pick your favorite function that we can integrate. Let's do sine. All right. What's the integral sign?
Negative cosine.
Negative cosine. So what we have is negative, and you take the derivative dx or something, ddx of negative 2 to x cosine of t, right? That's my integral. Plug in the upper limit. What's the cosine? Just plug it in. So I get negative cosine x minus cosine 2, right? Yes? Distribute the negative. Okay, so that's the integral. Now let's go ahead and take the derivative. All right, what's the derivative of negative cosine? Sine of x. And what's the derivative of the cosine of 2?
0 because of
See, the 2 is the constant, right? So it does nothing. Okay? If it's not a function of x or an x, it's not going to do anything.
Is there ever gonna be are they ever gonna like give us one like two different x?
Yeah, okay, they will not. The thing is, you could easily. It's just a chain rule. So it's the same thing. It's the thing at the upper limit times the derivative minus the thing at the lower limit times the derivative. It's not a calculus standard. I don't know why. So the answer is no, they will never give that to you, even though it's easy enough to do. Okay? All right, so they will never give it to you. All right, we okay with fundamental theorem of calculus? Yes? All right, for part 1, the way that they test it, without being like just a definite integral, is they'll give you either a graph maybe or a table, but they'll say that like the integral of from 2, no, they won't do that. Let's see, what will they do? They'll have you integrate it, and they'll say that what is it? They'll give you this answer. They'll say that the integral of f prime from is 3 or something, from such and such to such and such. I need a problem. Yeah, from 1 to 3. Let's do from 1 to 3 is 3, and they'll give you that f of big F, not F prime. F of 3 is 1. Find f of 1. That's how they'll test part 1. Okay, do I need to go through that? No, yes?
Isn't it just like a triangle?
It's not a triangle. They could give me a picture to find the area, right? They're telling me it's this. So the integral from 1 to 3 of f prime of x dx is integrated to get f of 3 minus f of 1. All right? So you know that this is 3, f of 3 is 1, and you can solve that for f of 1, right? Okay, that's how they're going to test fundamental theorem of calculus. That's how I will test fundamental theorem of calculus. All right, is that good? All right. What else do we need to know besides fundamental theorem of calculus? That's your fundamental theorem, Riemann sums, okay? Properties of integrals. The integral from a to a is 0. You still know that because you're not going anywhere. You can switch the limits, but if you do, put a negative out front. And you can add up integrals. The integral from a to b is the integral from a to c plus the integral from c to b, right? You can split it up if it, like, especially around absolute values. We did that with triangles. Remember that? Don't forget, if you have a triangle or a circle, don't, if you have an absolute value or a circle, don't integrate that numerically, right? Just draw the picture, right? Okay. You gonna see that in the test? Yeah, probably. Okay. If they ask you to find the average value, you need to know this formula. Do you? It's 1 over b minus a, the integral from a to b. That is also what they call the mean value theorem for integrals. Okay. Remember what an integral is represented. It's the signed area under the curve. So it's above the curve, it's positive. It's below the curve, it's negative. Please don't forget that. People forget that all the time. Substitution was the major player in this unit. Substitution we're going to use all year long. So you're going to see a bunch of integrals by substitution. All right. Multiple choice. Good choices of u. If you've got something raised to a power, u is probably the base. If it appears in a denominator or appears inside of parentheses or something, those are good choices for u, right? And I had some examples there, which, do I need to work out any of these 3, or are you feeling comfortable with those 3? Do I need to work out the first one? What would you let u be? Sine 3x. How about the second one? What would you let u be? Yeah. And on the third one, you let u be x over 2, because what's cosecant squared is a derivative, right? It's the derivative of cotangent, right? Okay, so that's the cotangent. All right, make sure when you're doing a definite integral, you change the values of the limits, right? Do not forget to do that. It is easy to do. All right. And, well, that one's easy. Okay. And remember, every once in a while, like this number 5, you're going to have to let u be 2x minus 1, but you're going to have to solve for x in terms of u to get the top. Do I need to do that one?
Yes.
Yes. Okay, let's do that one.
Wait, number 5.
Number
5, yeah.
5, yeah. Okay. Just to make sure you can do it, x over root 2x minus 1 from 1 to 5. So let me pull my smart board up. Okay. So in this case, u has got to be what's in the square root, right? 2x minus 1. So du is 2dx. So I need a 2. All right, so I'm going to divide by 2 because I multiplied by 2, right? So if I change this, right now I've got 1/2. The 2dx is the du, so I have x du over the square root of u. My problem is the x, right? This is a special case, but you can solve for x. Yes. So I'm going to use this. So u plus 1 is 2x. So x is u plus 1 over 2. So you put it back in the interval. I just put the 1/2 out there. That's right. So I made it 1/4. All right, how would I do this? Huh? Yeah, split it out, right? So this you can't do this any other way except to split them up both up. So it's going to be u over root u plus 1 over root u, right? 1/4 the integral of u to the 1/2 plus u to the negative 1/2. Yes. Change your limits. I haven't changed my limits yet. Let's see. When x is 1. U is going to be 2 times 1 minus 1 is going to be 1. When x is 5, U is going to be 2 times 5 minus 1. It's going to be 9. All right. And once I've done that, I can leave the other one behind, right? All right. Do I need to keep going, or you guys tell me? You just integrate now, right? Like you want to subtract. All right. That's probably the hardest interval you're going to see, right? Right there. All right, we okay with that? Yes? All right, and then don't forget, yesterday, I think it was yesterday, we talked about if the degree of the top is greater than or equal to the bottom, the only way you're going to be able to integrate that right now is use long division and simplify it and then integrate it. All right, do I need to do that last one? Yes, okay. So I have the integral of 2x squared plus x minus 1 over x minus 1. Where's my little thing? Integral, I forgot what the problem was.
2x squared plus x minus 1 over x minus 1.
Alright, so the problem is the degree of the top is bigger than the bottom. If the top are equal, you must use long division. Okay, so you're gonna long divide it. So you go, okay, what do I have to multiply x by to get 2x squared? 2x times x, 2x times negative 1. So my next step is to subtract. So I get 3x, right? Bring down the negative 1. So x goes into 3x 3 times, multiply, and subtract. So I have a remainder of 2, right? So you're going to write this as 2x plus 3 plus the remainder over the divisor. And this is really easy to integrate, right? What's the integral of 2x?
X squared.
What's the integral of 3?
3x.
And this guy, can you do it without substitution yet? Or?
2 times the natural log.
Huh? Right, u's going to be what?
X minus 1.
So du is dx. I dropped the dx, right? But it's there. Alright. So I'm going to have the integral of 2 over u. Du, what's the integral of 2 over u?
2 times natural log
2 times the natural log
of the absolute value.
of the absolute value of u,
X minus 1.
x minus 1.
Should we not, should there not be a 1/2
Did I drop a 1/2? No, I didn't drop a 1/2. Where's the 1/2 coming from?
Oh, never mind.
Yeah, just about. Okay. Fine. Okay. So when the top is the same degree or bigger, you must use long division.
Oh, you've got something for me?
And I think that's about it, right? So I haven't used a calculator for any of this. So I think there might be one calculator problem. I think I just gave you nah, it's fine. I don't think there is. All right. So that's pretty much it. The major player here, substitution. You're going to see that throughout the year. We learned all our integrals now. Other bases are kind of minor, but you will see some of that on this test. All right, like the derivative of 2 to the x or something like that.
I'll be right back.
Okay. Mean value theorem for integrals is just taking the average. That's a major player. All right, and the fundamental theorem of calculus, that's a major player. Okay. All right, that's your test. So you guys have time that you can work now. I don't have anything else to tell you other than work on your review. Everybody got a review? Okay, so, and you guys that are behind on your homework can work on that. Oh, wow. Am I good or what?